Hi there, it's Albert Luck from luckymaths.co.uk. I'm working through some questions from May 22's non-calculator paper today, focusing on questions where you can use mastery techniques. So I picked out some of the more worded questions, starting with this one, number 7, 3-marker. Simon buys some candles. Each candle costs £2. So I'll be setting up the diagrams from scratch. But we know that one candle is £2. So Simon is buying a certain amount of candles. He pays with a £20 note, he gets £6 change. So really, you've got to be clear on the structure there. That 20 minus 6 means we're spending £14 on candles. Now, of course, you may know exactly what you're doing here, but from previous work, I'm going to stick with what I've been practicing, because some students may get confused with the answer and write, maybe 14 down. 2 candles cost £4. 4 candles cost £8. 8 candles cost £16. So we know £16, we're not buying 8 candles basically. If we add together 8 plus 4 plus £2, there's £14 there. And if we add together 4 plus 2 plus 1, that means Simon bought 7 candles. Okay, this question now, a little bit trickier, 4 marks. Okay, don't give those out lightly, let's say. And the trick to this one is understanding about this electricity meter, that you are essentially having to subtract the 88,738 from the 89,198. Now, some students not confident subtracting, so I might just kind of show you a couple of other methods where you can make subtraction a little easier for yourself by kind of scaling up the question. So with this one, I suppose it's the problem is it's this 1 take away 7 on the third digit there in the hundreds column. So 8 take 8 is 0, 9 take 3 is 6, but then some students would struggle doing 1 take away 7, because then you've got to borrow from that, add 1 there. 11 take 7 would be 4, 8 take 8 0, 8 take 8 0. So we are looking to get 460 units first and foremost, but I suppose what you could do to make the subtraction slightly easier is to scale the numbers up. So for this one, eventually I suppose what we could do is add enough to the bottom number to get like a whole number. So like we could try and get it up to 89,000. So just going to show you an alternative. So it requires a bit of scaling though, so maybe it's not the best thing to do. First of all, if we add if I just add 2 to both top and bottom, we instantly get that, which again might not be as appealing because in the tens now you've got 0 take 4. So then maybe you need to take that, and then we think, well, actually let's add 60 onto that, and now to both top and bottom that becomes that. Now these are all the same calculation, by the way. You might think, oh, that's still a little bit trickier. So now if I try and I'm looking to round up to the nearest to get that bottom bit to 89,000. So if I add 200 on to both the top and the bottom, if I add 200 to the top, we get that. The bottom number is 89,000. And so when you take that away from each other now, it's literally going to just go 0, 6, 4, 0, 0, 460 straight in. So don't know whether that could be a useful tip with subtraction to maybe make, again, your life easier for some of the more complex ones you might have to do. Okay, so now we've talked about that, let's worry about these 460 units of electricity that are each costing us 16p. 460 lots of 16. I'm going to use the ratio table to multiply. 460 lots. So I'm actually going to go with 2 lots and 4 lots. Firstly, because I'll be able to add those together and then make 6 lots, which will become my 60 lots. And then I'm going to be able to turn the 4 lots into 400 lots. So this is my strategy. I'm kind of mapping it out before I start. Okay, the only work we need to do really for this is doubling. 1 lot is 16, 2 lots will be 32, 4 lots, 64. I've done the hard bit, I've done the doubling. But I'm not going to double any further because 4 times 2 is obviously not 6. If I add the 2 and the 4 lots together, they get me the 6 lots. 32 plus 64 is 96, which means 60 lots would be 960. Okay, pence. Okay, I've not been clear actually. Units and pence. 400 units is going to cost whatever 4 was times 100. 64 times 100. 6,400. So 460. Okay, just to be clear again, there's the 400, there's the 60. These are the numbers now, don't matter. 6,400 added to 960. Now, that is in pence. So you could work it into pounds. So I'd accept either answer as long as you're probably clear with your units, what you mean. Okay, generally, well, like I say, I think most students would go for converting that into pounds, but there's your 4-mark answer. Okay, I'm going to take the opportunity now to talk about fractions and try and explain fractions in a slightly different way. Just going to need a bit of space. Boxes. Right, so first of all, I've drawn out 12 boxes. There they are. And below, I'm going to do the same length diagram, but I'm going to turn this into 6 parts. Again, a bit rough, but again, it will show you roughly what's happening here. So on the top, to be clear, what I've drawn out there, this is my 5/12. The 12 boxes, just crossed, shaded in 5. And below, here's 1/6. 6 parts, and 1 of which I've shaded. Now, of course, at face value, because of, again, how I've drawn it, it might look like there's no real link here. But if I suddenly just convert those 6 boxes now into 12, hopefully can see that this becomes, there are now 2 12 shaded. So if I now, I'll use red still, if I add these two boxes obviously onto what we started with, 5/12 plus 1/6 must equal 7/12. Because the 2 red ones below, as I said, added to the 5 blue ones we started with, okay, obviously is taking up 7 out of the 12 boxes in total. So that's why we say 7/12. Write the answer however you want to, as long as it's in the form, 7 out of 12 or equivalent. Okay, now we've got a speed, distance, time question. One of these are my favorites in terms of using the ratio table, because the triangle, as I've explained before, I just feel doesn't work very well for students without understanding. So yes, Savio leaves his home at 7:30 in the morning. He drives a distance of 50 miles, great. He thinks he drives at an average speed of 40 miles per hour. Now that's the important bit, because we're going to break down using the ratio table. Just going to think how I'm going to do this. Okay, if he's gone 40 miles in 1 hour, he would travel 80 miles in 2 hours. So already, if he's going 50 miles to work, it's not going to take 2 hours, is it? Because that would be 80 miles. So trying to be logical with what you think about here. If 1 hour is 40 miles, that means that in half an hour, he'd have traveled 20 miles. And if we half that again, it means in a quarter of an hour, which is 15 minutes, he's gone 10 miles. So traveling 50 miles is where I'm going to use these two components. It's however you want to call it. It's 1 1/4 hours, 1 hour 15 minutes. Both mean the same. It's important which one you use, obviously, to help get the final answer, because we're not going to write 1 hour and 15 for the answer, because the question is, what time will he arrive from work? He's left home at 7:30. 1 hour later, 8:30, 7:30, add 15 minutes to that. He should arrive at work 8:45, and that's 3 marks. And again, doubling and halving the skills. Okay, another question on proportion. This is the recipes question, which is focused on, we've got 10 scones in the ingredients list. We're going to 25 scones, but we're focusing in on just the sugar. So the diagram I'll be setting out with the scones and, let's say, the grams, we are told 10 scones needs 40 grams of sugar. That means that 20 scones would need 80 grams. Again, that's double. And it means 5 scones need 20 grams. So to make 25 scones, we will add together the 80 and the 20, which means it will be 100 grams of sugar. Okay, percentage question. Increase 240 by 20%. So here's our starting value. So with percentages, all about, again, getting a good solid foundation. Don't actually need to do anything further than this because it's 20% we're looking for. So increase 240, well, that's what we started with, by obviously 20%. So we're going to be interested in these two, the numbers below these two boxes. Right. My earlier videos showed you how to do 10%, again by dividing by 10. 240 divided by 10 would be 24. 24 times 2 is 48. So if we're going to now increase, which again means to add, if we add together the 240 and the 48, the 3-mark answer is 288. Okay, and finally, again, one of my favorite kind of questions, the big 5-mark type ones you're going to see towards the back. However, this question in particular revolves around all the skills I've been using before. We've got ratio, fraction of an amount, and percentages all mixed in. So it's all about getting the ratio right to start with. And so what I'm going to do, again, going back to the standard kind of technique or the practice I use, I'm going to draw 3 boxes to represent the cars. Seven boxes for the vans. So we are told there's a total. Okay, really important. Total of 160 cars and vans together, which is because of the setup here. 160 therefore is going to be shared between all of the boxes. The question, 3 plus 7 is 10. 160 divided by 10 means each box is worth 16. Okay, but if we read the rest of the question, it's talking all about cars. So again, vans, the number of vans is not actually relevant. Okay, 16 plus 16 plus 16, 16 times 3. Again, however you want to work that out, it's going to give you 48. So there are 48 cars. And now we can go into part 2, where we're told 1 out of 8 of the cars use electricity. So what I would do here is going to create another bar model. So split that into 8 boxes. And that's the number of cars. 48. So because again it's 1 out of 8, if we split that into 8 ways, 48 divided by 8, 8 times 6 is 48. 1 out of 8 means 6 cars use electricity. And now we're going to work out 25% of the cars. Again, we're still talking about the cars, 48 cars. So for 25%, if we start with 100% is 48. Now, I know using my method with 10% and 20% will work. It's just, again, you'd have to be careful with that. So I don't know if it's worth, again, showing a slightly different way to deal with 25% as a unique, different method to what I'd normally do. And then I'll show it, let me call it my standard kind of way, which involves 10%, 20% and 5%. So basically to get 25%, which is a quarter, you can half it and you can half that. So 25% is 12. The other way to do it, of course, is keep with the basic fundamental of 10%, 20%, 5%, as I've demonstrated, which still will work. It's just that 10% becomes 4.8, 20% is therefore 9.6, double that, and 5% would be 2.4, which of course are decimals, but when we add those two numbers together to get 25%, we do still end up with 12. So it does work. It's a little bit more fiddly with the percentage. So maybe the other option I've shown might be better. Anyway, there were 48 cars to start with. We've worked out there were 6 electric, there were 12 diesel. 6 plus 12 is 18, which means we take 18 away from 48. That means there were 30 petrol cars. And that's the 5-mark answer. I hope this video has maybe shown you, because these are real GCSE questions to be clear, 22 marks available. 22 marks, again, doesn't seem like a lot, but I've barely really touched a lot of this paper. But what I have done is I've been quite consistent with the methods that I've done. 22 marks. That's a quarter of the paper, to be clear, using ratio tables and bar models. Okay, 22 marks Again, as I said, doesn't seem like a lot. 48, let's say, upwards would normally be the grade 4 kind of target score you'd aim for. But I started at question 7, guys, which means there's a good 10 or so marks before that for the first, maybe first 5 or 6 really, to get you going. So thanks for watching.